Yeah. Hello students. Hope you all are doing good. बच्चों, आज का टॉपिक है सिलिकॉन टेट्राक्लोराइड. Its formula is SiCl4. Now, if you read the formula from here, it is silicon tetrachloride. But if you read the same formula from this side, this end, it becomes tetrachlorosilane. So, in this way also, you can name this compound. Now, let's see the structure of silicon tetrachloride. Students, the structure of silicon tetrachloride is tetrahedral. It is tetrahedral in nature. You can see silicon atom is in the center. It is surrounded by 4 Cl atoms which are covalently bonded to silicon. That means it contains 4 sigma bonds, single bonds. Now the silicon atom in SiCl4 is sp3 hybridized. We know 4 sigma bonds, no lone pairs. That means hybridization is sp3. The shape is symmetrical. Now here third point is very important. Here silicon atom has vacant d orbitals. These vacant d orbitals, they are available for bond formation, which we'll see in the coming examples. Now let's see how this silicon tetrachloride is prepared. Students, elemental silicon is reacted with 2 moles of chlorine gas when it combines to form silicon tetrachloride. So its preparation is very simple. Let's see the next method. Here silicon carbide is taken. Silicon carbide is reacted with 4 moles of chlorine gas when we get silicon tetrachloride and CCl4. Children, both carbon and silicon, they belong to the same group, that is group 14 of P block. But see the difference in the behavior of these two compounds. CCl4 is an inert solvent, non-pungent, whereas silicon tetrachloride is a colorless liquid. It is fuming in nature. That means this liquid fumes in nature, fumes with pungent odor. The reason why it has pungent odor is the formation of HCl. It contains Cl, which when hydrolyzed, it releases HCl gas. Now see the next property. It is decomposed by water to form HCl. So this is the reason why it is pungent in nature, because it releases HCl gas when reacted with water. Another nature or another property of silicon tetrachloride is it is corrosive to metal. That means it will erode the metals and the tissues also in presence of moisture. Again, the reason is same. Why it is corrosive in nature? Because it releases HCl gas. Now let's see the point which is very important. The most important point which we discussed is it is decomposed by water to form HCl. Now here you see, in Google if you search, you will get this equation. Silicon tetrachloride reacts with 2 moles of water. That means when it is hydrolyzed with water, you get silica, SiO2 and 4 moles of HCl. Whereas if you see the textbooks, you will find silicon tetrachloride when hydrolyzed with 4 moles of water, we get salicylic acid and 4 moles of HCl. Now a question arises, which one is correct? Whether both are correct or one is correct and the other one is incorrect. So let's see how we can write the reaction. Now students, focus here because this is very important equation. We know valency of silicon is 4. So write silicon in the center, 1, 2, 3, 4. And 4 valencies are satisfied by Cl. Now when silicon tetrachloride is reacted with water, we know water contains oxygen atom and this oxygen atom has 2 lone pairs of electrons. Now here you see all 4 valencies are satisfied, but we know silicon has available d orbitals. It has vacant d orbitals because it belongs to third period. Its atomic number is 14. Configuration, if you write 284, that means third shell starts, and it has 3d orbitals available for bond formation. So what happens? This oxygen atom donates its lone pair to the silicon atom. The old bonds are not broken here. Due to the available d orbitals, it is in a position to accept the lone pairs given by oxygen. So what happens? Now see the structure, silicon 1, 2, 3. These are old Cl bonds. This is also old Cl bond, and oxygen, that means water is written in this way. Oxygen donates the lone pair. It forms a bond here. Now here you can see after donating the valency of silicon exceeds 1, 2, 3, 4, 5. So to satisfy the valency, again a molecule of HCl gets removed. So when molecule of HCl is removed, you can see Cl atom gets replaced by OH. Now we get the structure in this way. Silicon, Cl is replaced by OH, and 3 silicon atoms are present as it is. In this way, if you add again water molecule, in the same way, oxygen will donate lone pair, and one by one all 3 Cl atoms are replaced by OH. So in this way, 4 OH atoms surround silicon. And when you write the formula, you get H4SiO4. This is called salicylic acid. SiLiCiC, salicylic acid. Now let's say which one is correct, salicylic acid or silica. Now what you have to do, just remove 2 water molecules from salicylic acid. Let me write somewhere here, H4SiO4 minus 2H2O. If you remove 2 molecules of water, you will get SiO2. SiO2 is silica. So students, if you remove 2 water molecules from this compound, you will get silica. Hence, both the equations are correct. So I hope this topic is clear to you. It is a very, very important topic. Now let's see the uses also. Before ending, let's see the uses. It is used in optical fibers and in semiconductor industries as a starting material. That means silicon tetrachloride is used in making several other compounds. So out of all these properties, hydrolysis of silicon chloride, tetrachloride is very, very important. It is also given in NCERT part 1 of class 11th textbook under the heading P block. So please go through it. Any problems, any suggestions, please comment. Thank you all for your valuable time. See you all again in the next video. Thank you.